Greetings everyone, I'm Yan from Fujitsu Nanda Software Technology. As the speaker for the presentation today, please allow me to introduce you to the project developed by our team, an automated test solution based on Lava, which we named the AGL Extend Test. The process we're going to introduce is first, a brief overview of our automated testing solution, followed by some of the work we've done, some of the constructions we're still working on, and what we are going to do next step. Let's take a brief look into the AGL Extend Test. The goal of this project is to run a variety of tests in a simple and uniform way, and to generate a test report in a uniform format that is easy for users to read and understand. This project can test the stability and robustness of AGL and assist to ensure the stability of AGL unified code base. You can look at the image below, from left to right, as AGL test, AGL test-framework, and test suites. The first is AGL test, which is the entry command of the AGL Extend Test. Then, there comes the AGL test-framework, which is based on the pytest implementation and controls the operation of the test program, which includes what test to run, in what kind of runtime order. After running all the test suites, the test result will be analyzed and a unified report will be generated. And last, the test suites. The test suites supported by this framework include the test suites from ptest, which is a test framework provided by Yocto project, where the open source software self-test would run in. Test suite from LTP, Linux Test Project. LTP is a well-known open source test project. It has many use cases and wide test coverage. PyAGL, that is AGL's own test for application services. AGL test, some AGL-specific test suites. There are a number of other third-party tests as well. Based on what we talked about, AGL Extend Test has the following features. First, the supported test suites have wide test coverage. From the aspect of the test object, it is covered for Linux kernel, open source packages, services, and so on. From the aspect of classification of the test suites, there are functional tests, stress tests, benchmarking tests, and so on. From the aspect of the test suites upstream, there are ptest, LTP, AGL, and many other third-party test suites. Second, AGL Extend Test support many test scenarios. For example, when AGL releases a new version, AGL Extend Test works as a release test to provide quality assurance, or the AGL Extend Test can be used as a periodic test, let's say a daily test, weekly test, even a monthly test. You can even trigger this test yourself. For example, if you had made some changes to the code and you are not pretty sure if the system is still stable or not. Third, test content is not fixed. You can choose the test suite that you want to run according to your own needs. Fourth, After all tests are finished running, the test framework will automatically determine the result and generate a report of uniform format for you. Let's take a look at how AGL test frameworks support multiple test scenarios. The first type is that when a new version is released, or for regular testing. Its process is basically as follows. After being triggered, image under test will be built in the environment of Yocto. And then, under the scheduling of Lava, the Lava slave under test will run the tests, and the test results will be uploaded to a shared directory through RT-proxy. After that, user can access the shared directory to consult their own test reports. The second is to run AGL Extend Test after code modification. The first step is to compile the modified code to obtain the image that to be tested. In the second step, the tester should manually add a Lava job, specifies the image from the first step, and then Lava environment would automatically run the tests. The results of the tests will be uploaded to a shared directory through RT-proxy, which testers can access to find report for results. So, if you do not have a Lava environment to use, you can also run the test locally. In the first step, after specifying the feature of AGL test, you should compile and modify the code and generate an image that to be tested. In the second step, the compiled image is to deploy onto the board. In the third step, you should run command AGL test manually. In the fourth step, go to the var run AGL test directory to take a look at the test reports. After the AGL test finishes running, it generates two types of reports: the overall report and the single test suite report. First, let's look at the summary report, which summarizes the test result in a union of test suites. An example of a summary report is shown in the figure. The first part consists of summary report title and the time that the report was generated. The second part is the summary of test results, determining whether the test passed or not, and counting the total number of the test suites that was run, as well as the number of the test suites that has the state of passed, skipped, and failed. The third part is a table that describes the result of a test suite in detail. The first column of the table describes the final return status of a test suite. The second column is the name of the test suite, and the third to sixth columns record as the total number of cases running in the corresponding test suite, and the number of cases like pass, skip, fail, xfail, xpass in the test suite. Then we look at the report of single test suite. Unlike the overall report, the top header of this test report declares that it is a test report of specific test suite. The data counted in the second line after summary heading is the number of use cases excluded in the single test suite. And the status in the third row is divided into 5 situations. namely pass, skip, fail, expected failure, unexpected pass. In the table below the details heading, there are only two columns. The first column, a verdict of each use case, and the second column is the name of the use case that was executed in the test suite. The above content is a brief introduction to the framework, and there are some of the things that we have done recently. We recently made some optimizations to our framework. First, we've added leveling for stress tests. Due to the different performance of the boards, their upper limit of test pressure is different. In order to cope with this situation, we divided the pressure level for different boards into 3 levels of low, mid, and high, using low by default. Also, you can adjust this level when you need. This is adjusted so that before running AGL test, you can set the environment variable stress level to control the stress level of the stress tests under the current AGL test. Different pressure level corresponding to different settings, and the settings are described in a specific definition file called spec.json, which is stored in the same directory as the test script. Take a classic stress test CrashMe as an example. For CrashMe, we specify 4 parameters, which are in bytes, which controls the size of random data string, srand, a random number seed, and tries, the number of attempts required to exit normally, and nsub, the length of time that the test should execute. We write these parameters in advance to the spec.json file, and when needed, the command line will dynamically read each parameter and perform stress tests. In this pressure configuration, the low level is for Qmil platform. The mid level is for Raspberry Pi 4B. And the high level is for high performance development boards. You can also modify all the values according to your own needs. Second, we have made some formatting optimization to the HTML report. Let's start introducing the format optimization of the overall report. There are 2 significant optimization points. Optimization point 1. Compared with the old version of the report, the new version adds a timestamp, which can help you find a report generated by the test that you run at a certain point of time. Optimization point 2. We have improved the color matching. For example, pass of the green marker, skip of the orange marker, and failed of the red marker. These changes are mainly due to the fact that our framework may run thousands of test cases. If not distinguished from color, like the old version, that scene was totally whole black. Therefore, users will be more likely difficult to locate failed use cases. Secondly, we would introduce the report optimization to the individual test suites. For single test suites, based on the format optimization of the overall report, we have made some content optimizations for the test report of a single use case, and increased types of return status of the use case. Therefore, before the optimization, its state was only pass, failed, skip. But after optimization, there are, in addition to the 3 old states of pass, fail, skip, the expected failure and unexpected pass situations were added. So far, we have added 3 major types of test suites. The first is test suite from ptest, that is, OS's self-test under the yocto ptest output standard, which has 2 situations. The first situation, such as bash, busybox, glib2, and etc., they are already supported by the yocto ptest, so we just need to support them in the test framework. The other situation, as BC, that are not supported in the yocto ptest. Then we will provide yocto with patches to support the OS's self-test run in ptest, and then support them into the framework. The second type are tests from LTP, and there are many types of them. We have supported CVE testing, mass testing, POSIX conformance testing, and system call testing. The third type are some third-party open source tests, such as AIO stress, aforementioned CrashMe, StressNG, and many other things. This kind of test had their own test upstream links. We will first support this test into the test framework and then add their corresponding bitbake file in the meta AGL test layer to help compiling the tests into the image that to be tested. Now that we have covered some of the work we've done, let's talk about some stuff we are still working on. First, we need to actually run AGL Extend Test in the CIAT environment of AGL. So we choose to use the Lava environment of AGL. The environment address of Lava should refer to the link as shown. And the target board we selected for testing is Raspberry Pi 4B. Before the AGL Extend Test was applied, we did pre-check by manually adding a Lava job to verify that our test would work fine. We expected that the Lava job can call AGL test, where all test suites will be run, and finally test results will be uploaded to the shared directory. But during the execution of the test suites, a problem showed up. The issue we encountered was that a connection close occurred when the Lava job we uploaded ran for 30 minutes. And at this time, we have not found the real cause of the problem. We used Qmil to reconfirm, but did not find this issue there. So it seems to be an issue of Raspberry Pi. And the next step, we intend to switch Qmil to push forward. In addition to the above issues, we're still working to fix bugs in our AGL test framework. We are adding more test suites. The first category is related to OSS self-tests. And now we are adding CPIO and tar. We have submitted patches to the yocto community, still waiting for the review of the yocto community, and later on, we will add support for them in the AGL test framework. The second category, which is the test suite that ptest already supports, then we just need to add them, for example, the BlueZ5 and Wayland into our test framework. The plan for the future is of 2 parts. First of all, we need to continuously optimize our test framework. First, we need to fix some potential bugs. Second, we intend to add new feature to the test framework. We would like to deploy fast and slow test modes into the framework, which will be detailed later. Third, we also want to support more test boards. The current supported test motherboard is a Raspberry Pi 4. The next step, we're going to support QEMU x86-64 for the test. Then, we still need to add more tests. We're now continuing append the current test framework with pytest suite, ptest suite, and LTP suite. There's an explanation in addition of fast and slow mode mentioned earlier. Now, when the AGL test command is executed, all test suites are executed by default. Since some test suites take quite a long time to run, the total runtime will become even longer. For example, Python 3 will run for 1 hour and 40 minutes. CVE in LTP will run for 40 minutes, and the syscall will run for 3 hours. As more test suites are supported into the framework, the overall execution time of AGL test will become longer and longer, possibly exceeding 24 hours in the future. So it will not be suitable for a daily test usage. To solve this problem, we intend to divide test suites into 2 categories according to their runtime. Tests with a runtime less than 5 minutes are classified to fast tests, and tests takes greater than 5 minutes are classified to slow tests. When the user selects fast mode, only the fast tests are run. And when the user selects slow mode, only the slow tests are run. Regarding to the support for QEMU x86-64, there are still some issues that need to be addressed. One of the problems is that QEMU would face an insufficient storage issue due to the fact that we need to place both test files and log files onto the board. As shown in the figure, the current test log will occupy more than 5 megabytes of space. And the test increases, the logs will only occupy more spaces. The LTP file takes up 399 megabytes of spaces. And with the fact that only about 450 megabytes is still left in the QEMU image, at this moment, we will soon face the problem of running out of space. We're still discussing some options for this issue, such as we can appropriately increase the default compilation space for QEMU. We can delete part of the test logs, or we just do not run tests that take up a lot of space, and so on. You are welcome to discuss with us and send email to the AGL's mailing list to get in touch with us. That's the end of the talk. Thank you for listening.
Can you hear me?
Hey, yes, we can hear you.
Does anybody have any questions? We've got a microphone here. You can talk right with them.
So you mentioned that the running all the tests takes very long. What was the maximum time to run all of the test suites, kind of run everything?
Now we have added 20 test suits, and it's about spend 6 hours. So the longest test suit about 3 hours. So yeah, just like that.
That was all. Right.
No. The longest test suit is Python 3. It is a test suite from ptest.
Okay, I see.
Okay.
So if it's 6 hours, does that run? It can run on every commit, kind of NCI. Does that run on a daily build, or if not, how often does the full test run? Just on every release?
We plan for test after every release, and then we will run the quick test suite for the daily test.
Yeah. Sure. Yeah, but testing on hardware before integration is a good step forward, isn't it? You know, there's not that many projects do that. Sure. Sure. Yeah. There was sorry, this is not into the realm of questions now. I'm just talking. There was an objective to use OpenQA in AGL that I noticed some years ago, and the next talk that we're giving is actually about how we can use OpenQA on hardware as well. So it's very, very interesting, this talk. So thank you for the talk. It was great, and I think we can definitely think about how we can add to AGL some interactions with testing the UI on hardware as well. Like I say, sorry, that wasn't a question. It was just a statement. Anybody else?
Yes.
Yep, thanks for the talk.
Yes, thank you. Thank you for your time.